So today you might notice you're like, huh? 4.4, 4.5, we're in unit 6, which is true, but this is a refresher because we're going to look at graphing quadratics when it comes to solving. So before you graphed quadratics, if you were trying to find like the max or the minimum point, or we know it as like the vertex, but what if I'm just trying to solve it by graphing? So I'm going to refresh the first two with you, and then I'm hoping maybe someone can come up and do this third one, or maybe you do it on your own and you test it out to see if you remember. And then we're going to get into graphing in factored form because we did that together. And then your homework is just this sheet. See how it says homework, this sheet? So that will be up to you. So then we can spend the class time working on it, practicing graphing quadratics again, and solving. So basically it's like, where are the x-intercepts? That is going to be your solution. So going way back to unit 4, this was in vertex form. And I will remind you of our letters where we've got a general form where y is equal to a x minus h squared plus k. Do you remember what these letters are in charge of, or what they do to the parabola? We can start with A first since it's at the beginning. What is A in charge of? Yes, Blake? Stretching or compressing. So if the parabola is getting super, super skinny, or if we're compressing it, it's going to get super, super wide, right? What else does A do? What is it also in charge of, Aisling? It determines if it's a maximum or minimum, or if it's smiling or frowning. I can't... There, that's kind of rough. So if it's frowning or if it's smiling. Exactly. So A is in charge of those two things. What about H? What does H do? Yeah, Raf. It's a horizontal translation, exactly. So it's determining whether you're going left or right. If it's X minus H, does the minus mean I'm going left or right? Right. Yes, we're going right. Remember, it's the flip sign because you see negative and you think, oh, I'm going to the negatives, right? But a negative or minus means you're going to the right. So that means X plus H means you're going to the left. Exactly. I realize my left is your right, so this way. Perfect. And then last but not least, K. What does K do? It's the vertical translation. So if it's positive, you're going up, and if it's negative, you're going down. Right? So the easiest way to start graphing these is, where is my vertex? That's my starting point. And then we can do step pattern from there. So all of these things are kind of old. Like, we've done it before. We will practice again. So, okay. My vertex of this guy, what is it going to be? -2, -1. K stays as it is. We do not flip sign for K, but we do for H, right? Because the plus means I went to the left. So I went to -2, right? Axis of symmetry, that's that invisible line that kind of cuts the parabola in half, and it's going through the x-coordinate of the vertex, which is -2. Perfect. The stretch or compression factor. If I don't have an A value here, that means it's automatically just like 1 by default. 1 is really like not like a stretch or compression. So we can just say it's got a stretch or compression factor of 1. Neither a stretch or a compression. And will it be smiling or frowning? It's going to be smiling because A is positive. There's no negative sign in front, so it's going to be opening upwards. Or smiling like that. Now this was the one that was new that like tripped people up a little bit. Domain and range. This was the funky notation. We said all parabolas have the same domain, which is what? Shiza, yeah? XER, or we said this means X is an element of real numbers, meaning it can be anything. It'll extend out forever and ever and ever, and it will touch every X value from -infinity to +infinity, no restrictions. But we said Y has some restrictions, and that's dependent on where our vertex is. So in this case, my vertex, my Y value is at -1, and I'm opening upwards. So I know YER, such that, but what's the such that? What's the restriction? Yeah, Shiza? Y has to be greater than or equal to -1. Exactly. It can touch -1, and because it's opening upward, it's going to be everything above -1. If it was opening downward, it would be everything below -1. Hello, Miss Kelly. How are you? I'm okay. Yeah, absolutely. Perfect. So we said, let's start with our vertex. Let's plot that. So we know, okay, I'm going to -2, and then I'm going down 1. So I'll be down here. Right? And then do we remember our step pattern from way back when? Yeah, Sarah, what's our step pattern? Perfect. I'm just going to write it on the sign here. Whoa. Over 1, up 1, over 1, up 3, and then over 1, up 5. Right? So we said we were always going to go up by odd numbers. So then it would be by 7, then 9, then 11, and you would just keep going. So, okay, I'm going to take my point here, and I'm going to apply that rule to it. So we're going over 1, up 1. So I'm going to be hitting the line here. Whoa. There we go. And I'm going to mirror on the exact same side. So over 1, up 1. Right? The next one is over 1, up 3. So I'm going over 1 and then 1, 2, 3. So this will be where my next point is. And I'm doing the exact same thing on the other side. So 1, 2, 3. I will be here. That's enough points for me to sketch. I can't really go up any further because the next would be 5 and I'd go off the graph. That's more than enough for us to connect and draw our parabola. Ooh. Right, which try and get it as best as you can. It's okay if it's a little wobbly. Is it starting to come back to us from way back when, from Unit 4? Okay. Is that okay? Do you want me to rewind through that at all? Anything you want to clarify? No, we're good? We're okay over here? Okay, cool. I'll zoom out a little bit so you can still copy if you are. But the next one, the only difference is that we have an A value in front. We have that 2 in front. So that's going to mean that we're stretching. So our parabola is going to get slightly thinner, right? So everything is still the same of how we find our values, right? So am I okay to zoom in for this one? Yeah? Okay. Where's our vertex going to be at for this one? Yeah, Chloe? 3, -4, right? So we're changing this sign to be positive, and this one gets to stay the same. My axis of symmetry is going to be, yeah, Evelyn? 3, perfect. And this 2, is it a stretch or is it a compression? I hear a stretch. Stretch, perfect. It's a stretch, and we're going to say it's by a factor of 2, or by 2. Perfect. Remember, whole number, stretch, decimal, compression. Right? Direction of opening, am I smiling or am I frowning? Yeah? I'm smiling because A is positive, so we're opening upwards, so it's going to have a smiley shape, right? Domain, same for all parabolas, always going to be XER, but where am I going to be restricted to for Y? Right? So we know we're opening upward, and my minimum value is going to be at -4. Yeah, Georgia. Perfect. So Georgia says Y has to be greater than or equal to -4. It'll touch -4, and then it'll be everything above it. Right? So, okay, starting point is at 3, -4. So I'm going all the way to +3 and down 4. So I'll be over here. But now my step pattern is going to change, because before we would go over 1, up 1, over 1, up 3, and over 1, up 5. But do you remember what we do when A is not 1? Yeah, Evelyn? Evelyn says we have to times what we're going up by that A value. So now instead of going over 1, up 1, we have to go over 1, up 1 times 2, which is just 2. And I'm going to keep repeating. So over 1, and then instead of up 3, we have to do up 3 times 2, which is what? 6. Thank you. And then same thing. Over 1, up 5 times 2, which is 10. Perfect. Don't know how much we'll be able to fit on this graph, but we'll try our best. Right? So, okay, we said we have to go over 1, up 2. So, okay, I'm going to go over 1, up 2. So I'll land here, and I have to do the same thing on the other side. Over 1, up 2. So at 2, -2. Next, I have to go over 1, up 6. Okay, 1, 2, 3, 4, 5, 6. I'm all the way up here at +4. And same thing on the other side. 1, 2, 3, 4, 5, 6. and that's all we can fit. So you can see this has been stretched. It's a little thinner than our first one that we drew in example 1. And I'm just going to try my best to connect. Okay. Perfect. Is that okay for you? Mm-hmm. Okay. Would you like to try example 3 on your own? We take the training wheels off and we review, and then maybe we can have someone come up to the front and do it? Okay. I'll give you a couple minutes, practice it, and then you let me know who wants to come up and do it, okay? Sheila, you already want to do it? You want to volunteer? Okay. Did you do it first? Do you want to work out a solution and then do it? Okay, perfect. And I'll, Sheila, tell the people who are watching. Okay, we're going to give our attention to Sheila at the front.
So, first of all, the vertex, since it's positive, we're going to turn it into a negative for 1. So it's going to be -1 and +4. And then for the axis of symmetry, x equals -1 because, yes. And then, since it's a negative, except there's no number, it's going to be like there's no compression factor, so it's just going to be -1. And the direction is opening downward because it's a negative, so downward, or upside down smiley face. And then the x value, the domain, is x r, and the y is rest center equal to 4 because that's the maximum. And then to like graph it, it's just like 1, 1, 1, 2, 3, and then 1, 1, 2, 3, 4, 5. 1, 1, 2, 3, 4, 5. So here, and then we're just gonna graph it. Done. It's a really bad graph.
Okay. Thank you, Sheila. That looks great. Right? It doesn't matter if it's wobbly, it's okay, right? As long as it's got that curve shape, right? What I don't want to see, which I saw in some, was this. The point of a parabola. It is not pointy. It is a curve, right? It's meant to look like a U shape, right? So this we did in the past. So you can now do this in factored form, which is what we've been learning, right? So putting it in terms of like your x-intercepts and solving that way, right? So these are the steps to do it. We've reviewed these, but ideally you have your x-intercepts. We learned something last unit called the AOS equation, or the axis of symmetry. And it's just where you're taking the average between your two x-intercepts because you're trying to find their middle point, right? That's where your vertex is going to be. And then once we find what that middle point is, we can just plug that into our equation, and that'll give us the y value of our vertex. So that'll tell us whether we're going to be opening upward or downward, right? So for example, with this one, okay, what are my x-intercepts here? We practiced this yesterday. What would these two be? This is going to be x equals, yeah, Chloe? -6. So I'm flipping the sign when I take it out of the bracket. And same thing, this one will be -2. Those are my two x-intercepts. I can plot those right away. Right, so at -2, I would be here. I'll keep it in pink. And at -6, I'd be right on this edge here. What I don't know is my vertex going to be up here or is it going to be down here? Right, I can't tell. Or where exactly is it going to be? I know I'm opening downwards because A is negative, so I'm going to be frowning. So I know it should be up here, but where? That's what we need to find. So this was our step 1. We identified our x-intercepts, but now I have to use the AOS equation. So to jog your memory, it is x1, or your first x-intercept, plus x2, your second one, and we just divide by 2. So it's just the average. Right, so I'm going to use these values, not these values in the bracket where they're positive. I'm going to take the ones that we used, or we took them out of the equation. So this is -6 plus -2 divided by 2, which that should give me -8 on top. And -8 divided by 2 is just -4. So I know, okay, my vertex is going to be in the middle right here, but how high up do I go? we're going to take this value and we're just going to plug it into the equation that it gave us to find what y is. So that's it. So y equals -1, and then I've got -4 plus 6 and -4 plus 2. Which, okay, what is this bracket going to simplify to? -4 plus 6. What is that? Huh? Did you say it? No? What's that one? 2. Thank you. +2. Whereas this one, -2, the opposite. So, okay, I've got -1 times 2, which is -2, and then -2 times -2 is going to make +4. A negative times a negative makes a positive. So, okay, we know, therefore, our vertex is going to be at -4, +4, which we can now plot. So, -4, +4 is going to be right here. That's more than enough for me to connect. We can do step pattern if you'd like to be super, super, super exact, but this is enough information. So I'm going to just go ahead and connect this. And that's more than enough. Voila. So it's opening downwards. Those are our x-intercepts and our vertex. Done. Right? Okay. Would you like to do this one together or on your own? Do we fear the fraction? Right? The fraction just means it's a compression, right? So it's going to be wider opening, right? So same thing. We can maybe start this together. This is going to be what for my x-intercepts? X equals -5. Thank you, Kara. And x equals +3. Perfect. So I can go ahead and plot those, right? So -5 is over here. And 3's all the way over here. So we got some big distance between. So I need to find the middle. Again, where's my vertex going to be? Up or down? But I need to find where. So if I do the AOS equation, that's going to give me, right, we're averaging them. So -5 plus 3 all over 2. -5 plus 3. What is that, Ashley? Put you on the spot. -2 all over 2. Which is just going to be -1. Perfect. And then lastly, that's going to be my x value. So I know here is our middle, our dead set middle in between, but how high or how low should I go? That we need to plug into our equation to figure that out. So that's going to be y equals 1 over 4 times -1 plus 5 and -1 minus 3. So, okay. We'll worry about the fraction last, so don't worry about that too much. Let's simplify the brackets first. So -1 plus 5, or 5 minus 1. Same thing, which is just what? 4, yeah. Right? -3 minus, or sorry, -1 minus 3. -4. So, okay. This is really just saying, like, 4 times -4 is -16. Thank you, Zambuda. And if I'm saying a fraction times this, the same thing as if I'm saying I'm putting this on the numerator and we're going to divide it. So -16 times 1, and then dividing by 4. Which, what does that leave me with? Yeah. -4. Thank you, Chloe. So again, we're at -4. So that's our vertex. So our vertex is at -1, -4. Perfect. Which I can go ahead and plot. So -1 and all the way down to -4. Right? That is a super wide parabola, but again, enough for us to do the curve. Perfect, which try and be as accurate as you can. It's okay if it's a little wobbly. Perfect. Is there anything you want to go over on this page? Anything you need to refresh, practice a little more, or do we feel okay with these concepts? And you have your package, like, unit notes from this unit. So you could always flip back to unit 4 and review, like, okay, how did we do this again? How did I graph this? If you need extra practice. So this is what we're going to be working on today. I would like to do the first 2 with you since this sheet is your homework. So I want to do the first 2 with you just so that you can get comfortable with it. And then I will give the rest of the time for you to work with your pairs. Mr. Figueredo and I can walk around the room and help you as well. But the as well, yeah. So this page and that one. But the only new thing that's added to this lesson that we didn't do in the refresher is this equal to 0, right? And when we set it equal to 0, we're just asking, where is x when y is equal to 0? Or where are we crossing the x-axis, right? Where are we touching this line? Right, so that's the only new thing. So you might have to practice graphing again, and then solving means state your x-intercepts, right? I'll tell you after, don't worry about it. Okay, so this one, what information is it telling me? I've got this plus 1, what does that correspond to? A, H, or K? Yeah, K. So this means I'm shifting up 1 unit. Right, if you want to make a little note. And then this negative x squared, that's my A value. So that tells me whether I'm smiling or frowning, which in this case, negative. Am I smiling or am I frowning? I'm frowning, exactly. So I'm opening downwards. Anytime you have a plus or minus on the outside, that's like not in brackets, right? If it's in the brackets, that's our D value. If it's on the outside, just on its own, that's our K value. So this means we shifted 1 unit up, and we're opening down. So I'm going to be frowning. Oh my. Oop. There we go. Okay. So in this case, there we go. I had a little bit of a glitch. So I know my vertex is going to just be at 1 or at 0, 1. Because I did not shift left or right. I only went upwards. So I will be starting here, right? And now downwards, I need my step pattern. A is -1. The negative just means I'm going downwards, but it's going to be regular step pattern, the 1, 3, 5 rule. So, okay, I'm going over 1, down 1, over 1, down 3, and over 1, down 3, and I don't think I can fit 5, so that's more than enough. And I'm going to connect. Perfect, right? My solution to this, or what it's asking me basically to find from graphing, are these 2 points here. That is your solution. Where am I crossing the x-axis? So my solution I can write down here, what are my x-intercepts, looking at the graph? Oh, who said it? Yeah? -1, and what's my second one? Because I've got 2 points. +1. Those are your 2 solutions. That's it. That is all you're stating. So it wants you to graph, and it wants you to identify. Oh my God, everyone's like buzzing me now. I'm so popular, you guys. It just wants you to know, or state, I should say, where you're crossing the x-axis. That's it. Those are your solutions. You don't have to do anything else. You don't even have to do these notes. I just put it there for you to practice, right? Even with B, have I stretched or compressed by anything? Do I have an A value? No. Have I moved left or right? Have I? Yes. What have I moved left or right by? 3. And where did I go? Left or did I go right? I went 3 units right. Right? This is my D value. So I moved 3 units right. Did I go up or down? Up? Did I? How? How do I know? Do I have a K value? No, so the A value, I would be opening upward, but I didn't shift up or down because I have no plus or minus anything on the outside. So that's the only thing that has happened. I have just shifted 3 to the right. So I know my vertex is going to be at 3, 0. That's it. And then like Kara said, we are opening upward. There's no A value in front, so I know it's just my regular 1, 3, 5 rule. That's it. So over 1, up 1, over 1, up 3, and that's all I can fit. I can't go up anymore. And that's enough to connect. In this case, I am only touching the x-axis at 1 point. My vertex is on the x-axis. So therefore, I only have 1 solution to this, right? Which is my x value of the vertex. So x equals 3. That's my only one, right? So I would like you to spend the rest of the time trying these ones and graphing and solving. And then on the back, you notice it's the same thing. They just want you to do 3 graphs on one. So maybe color coordinate, right? Or take a highlighter, or even just do like different lines if you want to do like dotted versus a solid, however you want to distinguish it, make sure that's clear. The only ones that are different from here to here are these ones are equal to 0, these ones are not equal to 0. How do I make something equal to 0? What do I do with these things on the other side? I just got to bring them to the other side. So for example, this one, if I bring 5 over, this is really just going to be 0 is equal to 5x plus 4 squared minus 5. Now you can clearly tell what your vertex is, right? Your vertex is going to be, this is your H, this is your K. Or sorry, I was calling it D before. I'm in grade 11 mode. That's why, because we call it D in grade 11. This is H and K. I'm sorry about that. So this is your H, -4, and then your K, -5. Now you can graph. Same thing with this one. If I bring over -4, this is really going to be what? -x squared plus 4. Exactly. Which you can see, oh, I shifted 4 units up and I'm reflecting downwards. That's it. So that's all you have to do when you have something equal to it. That's not 0. Just bring it over. Make it equal to 0, right? And then graph. And then just state whatever the solution is in this space here if you have room. That's all. So the rest of the time is for you to work on this. Is there anything from yesterday's homework that you want to take up together? Anything you want to clarify? No? You feel good about it? Okay. I will pause.